guys, my name is Hanifatul Takir Fauza. Here we are want to discussing about the next type of welding, which is submerged arc welding. Let's begin. Submerged arc welding is a welding or process to joining a metal that involves a formation of arc between bare metals electrode, and the workpiece. The blanket of powder flux generates a protective gas shield that protect the weld zone. And we go to the illustration of submerged arc welding. On the left side, there is a name of part, which are the DC power supply, the workpiece, submerged arc, the weld pool, covering flux, and electrode wire. And on the right side is the illustration of the process of submerged arc welding that will be explained by my friends. And we go to the next, which is the application of submerged arc welding. Basically, this type of welding is used on the big plate fabrication work. It can welding some types of material such as structural shapes, manufacturing of machine, tank, and vessel, and the last is surfacing and build up work, maintenance, also repair. And then we go to the next slide, which is the process limitations. Basically, every type of welding have their limitations. Also for this type of weldings, the first limitation is on the welding positions, and it limits on the strike positions. The second one is the primary usage for weld might also low alloy, high strength materials steel. The third one is the high heat input and slow cooling cycle that can be problem when welding quenched and tempered steel. Of course, this will be need more consideration on the heat input that the material have each have, because they have different limitation on the heat input. And the fourth one is the required to multi-pass weld, because the one or the single pass only acceptable for the mild steel. And the last is the inability to see the arc and the paddle might be the problem on reaching the root of groove welds and properly filling and sizing. And then the next one is the process of welding, which will be explained by my friends Maria Anggi Octaviani.
The principle of operation, it utilizes the heat of an arc between a continuously fed electrode in the work. Let's see the figure here. It shows what is the process diagram is look like. And actually there will be two materials are used in submerged arc welding. The first one is the welding flux and the consumable electrode wire. And the granular flux is coming out from the hopper, and the directions of the travel of this machine is going to left. And the heat of the arc, which produced by the electrode wire, melts the surface of the base metal and the end of the electrode. The metal melted of the electrode is transferred through the arc to the workpiece, where it becomes the deposit weld metal. And actually, the weld is submerged under this layer. It contains the slag or solidified flux and the unmelted portions of slag or the unused flux. And the vacuum system will recover the granular flux. For more information, let's see the video here. The slag is removed.
Then the other types of welding process is gas metal arc welding or GMAW. Gas metal arc welding or GMAW, or formerly known as metal inert gas or MAG, is the most common industrial welding process. This welding was first invented in the year 1940 for welding aluminum and other non-ferrous materials. The concept is combining two pieces of metal together by an electric arc from consumable metal electrode. To produce this arc, it requires a constant voltage and direct current power source. And then this is also use silane gas, usually argon and helium, along the wire electrode because these two are most economical and iron. It heats up the two metals to be joined. It also protects the weld from atmospheric contamination. The process can be semi-automatic or automatic. It is suitable for pushing or welding most ferrous and non-ferrous metals such as mild steel, stainless steel, or aluminum. And then the metal transfer in this process takes place in four primary ways, and they are globular, short-circuiting, spray, and full spray. And here are the circuit diagram or G of GMAW or MAG welding process. And for the working principle, as we can see in the picture, the first is direction of the travel of the equipment, which is from the left to the right, and 2 is contact tube, 3 is electrode, 4 silane gas, 5 molten metal weld, 6 is the solidified weld metal, and 7 is the workpiece. Firstly, the electrode wire from the wire feed unit and silane gas supply is attached with the welding gun, which is the whole body of the equipment. The positive terminal of the DC power source is connected to the welding gun and the negative terminal is connected to a clamp. The clamp is connected to the workpiece to be joined, and the welding gun is brought near the workpiece, and as the trigger is pressed, the arc is produced at the tip of the welding gun. The arc produced melts the electrode wire and it gets deposited in between the two metal pieces to be joined and form a slug-free weld. Here, a silane gas also starts to spread as the arc is produced. It protects the weld from reacting with atmospheric air and prevents weld from contamination. The weld from in-gas metal arc welding is free from slag, therefore it is clean and efficient process. And for the next explanation may be explained by Bilkis.
So, my name is Bilkis, and I'm here for explaining equipment, advantages, and disadvantages of gas metal arc welding. First, the equipment. So, the first is there is power supply, wire drive, gun, and the shielding gas supply. So, for the power supply, there is two specification. First, using constant current. So, the arc length is increasing as the CTWD increasing. So this kind of specification is only suitable for large diameter, large weld model applications. The next is the constant voltage. So as the CTWD decreases, the current would be increasing, and it makes the voltage and the arc length remain the same. So you could see in this picture, the left side is the constant current and the right side is the constant voltage. So when using constant voltage, no matter how long the CTWD is, the arc length would remain the same. And the second is the wire drive. So the first is the range for solid or metal core electrodes is 0.6 until 1.6 millimeter. So it provides magnet motor for fast starting and stopping of the feed system. And the effective range of wire feed speed is around 70 and 800 inches per minute. So this is the three kind of wire drive: LN15, LN9, LN10, and LF72. And this is, you can see in this picture, is there is 5 accessories for the wire drives. The next is the spool gun. So this is the spool gun, and this is the gun that is using push-pull system. So basically, The gun is used for delivering aluminum and packages of electrode to the arc, and the smaller the diameter of the electrodes, the more difficult it is to fit. And for the spool gun, the standard electrode is around 200 and 250 millimeter, so it can push around that millimeter electrodes to the arc. The next is the advantages of GMAW. First, it could join a wide range of material types and thickness. It also has simple equipment components and has high electrode efficiencies around 93 and 98% compared to the other. And it also easily updated for high-speed robotic, hard automation, and semi-automatic welding applications. And also, it has lower hydrogen weld deposit, less than 5 milliliter per 100 gram of weld metal. It also has lower heat input and lower cost electrode. However, the GMAW also has limitations. First, the lower heat restricts its use to thin materials. Second, the higher heat input of axial spray is restricted to flat or horizontal welding positions. Next, the high heat input axial spray transfer also restricts its use to thicker base materials. Thus, the use of argon-based shielding gas for axial spray and pulsed spray transfer modes is more than 100% of carbon dioxide. So this is the limitation for the GMAW. I think that's all for me, and you could move to the next presentation materials. Thank you.
Hello everyone, my name is Muhammad Dafranali from Mechanical Engineering Course 2019, and here I'm gonna talking about the electron beam welding. What is electron beam welding? Electron beam welding is a fusion welding process in which a beam of high velocity electrons is applied to the material to be joined. In this welding, the workpiece melts as the kinetic energy of the electrons is transferred into the heat upon impact. It provides industries with the highest quality welds and machine design. Before we go further to the material, let us first talk about the electron beam. In an electron beam welder, electrons are boiled off as the current passes through the filament, which is in a vacuum enclosure. The beam is come from an electrostatic field generated by a negatively charged filament, by a scap, and a positively charged node. They accelerate the electrons to about 50% to 80% of the speed of light and zaps them into a beam. There are several processes involved in electron beam welding. The first one is that the electron beam gun has a tungsten filament which is heated and freeing the electrons. The free electrons are accelerated from the source with high voltage potential between the cathode and anode. The stream of electrons then pass through a hole in the anode. The beam is then directed by magnetic forces of focusing and deflecting coils. This beam is directed out of the gun column, strikes the workpiece. The potential energy of the electrons is transferred to heat upon impact of the workpiece and cuts a perfect hole at the weld joint. Molten metal fills in behind the beam, getting a deep finish weld. There are several steps that involve in electron beam welding. The first one is joint preparation, the second one is cleaning of workpiece, the third one is fixturing of workpiece, the fourth one is demagnetization of the workpiece, the fifth one is setting up workpiece in the chamber, the sixth one is pump down air from the chamber, and the last one is carry welding process. There are various classification of the electron beam welding. The first one is depends based on the accelerating voltage. It divides into two. The first one is the high voltage machine with an operating voltage of 150 kV, and the second one is the low voltage machine with an operating voltage of 60 kV. Based on the pressure, it divided into three types. The first one is high vacuum machine, the second one is fine vacuum machine, the third one is atmospheric machine, or also known as NVEB welding. And by the machine concept, it divided into 6 types. The first one is the conveyor machine, the second one is clock system, the third one is all-purpose EBW machine, the fourth one is local vacuum machine, the fifth one is mobile vacuum machine, and the last one is micro and fine welding machine. If we compare between conventional welding and electron beam welding, there are several things that makes the electron beam welding to be better than the conventional. The first one is that EBW is suitable for a variety of difficult applications, such as welding starters on which the reverse side of the butt is inaccessible, gravity welding of thin metal, and welding in various spatial positions. The second one is that this welding provides a low level of overall heating of the structures and has the ability to vacuum the inner volume simultaneously, which is suitable for sealing instruments. Because EBW is an automated process, the welded joint quality is consistent. The third one is that the process does not require shielding gases, tungsten electrodes, or edge preparation for welding thick metal. The fourth one that it can be used to weld some joints that cannot be made by other welding processes. The last one is that compared with the arc welding process, EBW improves joint strength for about 15% to 20%. And here are the advantages of electron beam welding. In vacuum, it can be used for thin and thick plate welding. The second one is that it has extremely narrow seams. And the third one is that low overall heat input that can result into low distortion and welding of completely processed components. The fourth one is high quality speed possibility. The fifth one is no shielding gas required. The sixth one is high process and pan efficiency. And the last one is material dependency, often the only welding method. At atmospheric condition, it has a very high welding speed, and it also has a good gap bridging to problems with reflection during energy entry into the workpiece. However, there are still some disadvantages of using electron beam welding. In vacuum condition, the electrical conductivity of the material is required. It also has high cooling rates that can be resulted into hardening and making a crack. It also has a high precision of seam preparation, and the beam may be deflected by the magnetism. It can also form X-ray formation. The size of the workpiece is limited by the chamber size, and the last one is the high investment because it's expensive. At atmospheric condition, the first one it can also result into the X-ray formation. The second one is the limited sheet thickness, maximum 10 mm. The third one is the high investment, and the last one is small working distance. There are various fields of application in industries for the electron beam welding. They are automotive industries, aircraft and space industries, mechanical engineering, tool construction, nuclear power industries, power plants, fine mechanics and electrical industries. The last one is job shops. Electron beam welding also can be used for various types of material. The first one is for almost all steels. The second one is for aluminum and its alloys. The third one is the magnesium alloys. The fourth one is copper and its alloys. The fifth one is the titanium. The sixth one is the tungsten. The seventh one is the gold. The eighth one is the material combinations such as copper with steel, bronze with steel. And the last one is for the ceramics, electrically conductive.
Hi everyone, I am Yasinda Dewi, and here I want to explain about one of the type of fusion welding process. Fusion welding can be defined as a melting together and coalescing materials by the means of heat. And the type of fusion welding that I want to explain is laser beam welding. First of all, what is laser beam welding? Laser beam welding is the manufacturing process to joining two or more pieces of materials by utilizes a high-power laser beam as the source of heat. This process can be done without contacting the welding tools to the surface that is being welded. Because of the laser beam welding that can be focused into a very small area, the beam has high energy density and deep penetrating capability. This process is suitable for welding deep and narrow joints because the laser beam can be directed, shaped, and focused on the workpiece with the laser spot diameters that can be as small as 0.2 millimeters. So, there are two types of laser beam welding process. The first one is heat conduction welding, where it can be done by heating the workpiece above the melting temperature without vaporizing, and the heat transferred into the materials by the thermal conduction. And the second type of laser beam welding is keyhole welding, which can be done by heating the workpiece above vaporization temperature and digging deep into the workpiece to form a keyhole. Laser beam energy is transferred into the material by a cavity filled with the metal. The figure here shows the comparison between heat conduction welding and keyhole welding. Next, how laser beam welding process can work. The laser beam welding works on the principle that when the electrons of an atom are excited by receiving some energy, and after some time when it returns to its ground state, it emits a photon of light. The concentration of these emitted photons is increased by the excited emission of radiation, and we get high energy focused laser beam. The light amplification by stimulated emission of radiation is named as laser. There are several parameters in performing the laser beam welding, such as power density, welding speed, laser pulse waveform, laser pulse width, and the effect of defocus. The most important part is the first two parameters. High power density makes the surface layer can be heated to the boiling point in the microsecond time range. So when we have higher power density, we will have shorter time range. And the power density that is commonly used in LBW process is in range between 10 to the power of 4 to 10 to the power of 6 watt per centimeter square. Second important parameters is welding speed, which affect the heat input per unit time. So for example, if you have too low welding speed, it can result in too large heat input, which can cause the materials that are welded can be easily to be burned. And when you have a too fast welding speed, it can result in too small heat input, and this can cause the workpiece cannot be welded well. Then here is some of the main equipment that commonly used in laser beam welding. First one is of course laser beam machine, the machine that is used to generate laser for welding. Second one is shielding gas. This can be used to prevent workpiece from oxidizing. And the third one is power source. A high voltage power source is used to the laser machine to produce a laser beam. Then we have also computer-aided design and computer-aided manufacturing. Here I have two examples of laser beam welding. The first one, this is the manual laser beam welding process. At first, we need to weld two parts of materials at several points to make them can stick together. Then we use other workpiece to make sure the laser movement is in a straight line. And here is the welding process. Then this is the final result. And the second example, this is the laser beam welding process that are done by using the computer program. So at first, both of the components are held by hand, and it is welded at some point between those two parts so that those two parts can stick together, and then it will bend to the welding machine. So here is the laser welding process. As you can see here in this screen, you can see the welding path during the welding process. this is the final result of this process. There are many advantages of laser beam welding compared to the other welding types, such as the whole welding process can be easily automated using computer-aided design and manufacturing setup, can weld small and thin components, can easily work on high alloy materials, can be used in open air without using vacuum condition. No electrode is used in the process because here we use laser, and no form of tool wear occurs because the welding tool is not directly touch the welding surface. Besides of those advantages, there are also several limitations of laser beam welding, such as rapid cooling rate may cause cracking in some materials, high capital cost for equipment, optical surfaces of the laser are easily damaged, high maintenance and setup costs, limited to depth of 1.5 mm, and it is not portable. And here are some of the applications where we can use laser beam welding. First is automotive industry, where large volume production is required. Then electronics industry, food processing industry, medical, automation, robotics, and aircraft industry, and also in making jewelry. Why we can use laser beam welding in making jewelry? Because in making jewelry, usually we are dealing with the small parts, right? And laser beam welding is suitable for welding the parts that is very small. Here I also have some list of the materials that can be processed by the laser beam welding. So this all about the laser beam welding process, and thank you.
So the next process that we will explain is about roll bonding. What is roll bonding? Roll bonding is basically a solid state cold welding process obtained through the flat rolling of sheet metals. In roll bonding, two or more layers of different metals are passed through a pair of flat rollers under sufficient pressure to bond the layers. The pressure is high enough to deform the metals and reduce the combined thickness of the clad material. And the process can be performed at room temperature or at warm conditions. The strength of the roller bonds depend on the main process parameters, including the rolling condition, which are entry temperature of the sheets, amount of thickness reduction, rolling speed, etc. The pre-rolling treatment condition, which are annealing temperature and time, surface preparation technique, etc. And the post-rolling heat treatment. So, how is it done? How the roll bonding is done? The first is, of course, prepare the metal, the layer of metal, which is flat plate metals, and the second is surface treatment. The surface treatment is including stretch, clean, and grease of the surface of the metal plate in order to increase their friction coefficient and remove any oxide layers. After that, we stack the metals, the layers of the metals, and we preheat. In the warm roll bonding, we preheat the layers of the metal in order to increase their ductility and improve the strength of the weld of the bond. And the fifth is the rolling. It is the process when we combine the layers of the metal into one layer and decrease the thickness. Then and the last is next processes. The next processes is including the cutting or other manufacturing process that we will do after we combine the layers. And after this, the roll bonding also have advantages and disadvantages. This disadvantage and disadvantages will be explained by Fitri. Please, Fitri.
So, first, what is actually the advantages of this process? Why should we use roll bonding process? First, it has wider application. For roll bonding process, it can be used to join both two similar and dissimilar metals. It also able to join some metals that cannot be joined using the traditional welding process. For example, when joining the steel or stainless steel to nickel. The second one is that this process is cost effective. There are actually two reasons why this process is cost effective. The first one is that in this process, we don't need to add any materials so that we simply use the metals itself. And then the second one is that it is cost effective because, as I said before, that it can be used to join some metals even when the metals cannot be joined using the traditional welding process. The third one is that it produces higher strength metal. As Nico said before, that this process is actually done by combining pressure and temperature and reducing the thickness of the metals. So, when the roll flattening process breaks down the oxide layers of the metals, it will expose the fresh metals. And then when the fresh base metal and the clad metal will share their electrons, which form a high-strength roll bonded metals. Last but not least is that it produces uniform and stronger bonding. So we all know that the roll bonding is actually making two metals become one, which will produce a uniform bonding between them. And as I said before, that the fresh base metal and the clad metal sharing their electrons, meaning that they will have a strong bonding. Okay, next we are going to talk about the disadvantages of using this process. So there are some drawbacks that might occur because of this process. Those defects are categorized into two, which are internal and surface defects. For internal defects, it is very dangerous because for the internal defects, we cannot see it with our naked eyes. So it should be examined using some machine to see the defect inside the metals that we roll. And then for the internal defects, for example, porosity. Why this internal defects is very dangerous? Because if we don't do the examination on the metals that we have rolled, it might contain some porosities inside. So for example, it has porosities inside, and then we just use it in the field, and it might lead to catastrophic failure, which is very bad and dangerous. And then the next one is the surface defects. Surface defects is caused by inclusion and impurities in the original cast. There are some examples of surface defects such as wavy edges, cracks, and alligatoring. For wavy edges, it is caused by the roll itself. As we know that a roll bonding process is rolling the surface of the metal, right? So if we roll it, there might be possibility for the surface to form a wave form. So then the next one is cracks. Cracks exist due to poor material ductility at the rolling temperature. So if the materials that we rolled is not ductile enough, the roller will continuously roll, right? So it will force the metal to shrink to reduce its dimension. Therefore, it might lead to the existence of cracks on the surface of our metals. Last but not least is the alligatoring. Alligatoring caused by the non-uniform bulk deformation. So that's all about the roll bonding process that we can deliver to you. There are many processes of joining in a manufacturing field that will be delivered by my friends.
Hello, my name is Larasati Apriliana Nugroho, and in this video I will explain about the ultrasonic welding. Let's start with its definition. Ultrasonic welding is one type of welding process that needs ultrasonic vibration, which is a high-frequency vibration with a range of 20 kHz until 30 kHz to weld and join it two different parts with solid-state weld. The equipment is the ultrasonic weld machine. This machine has 5 important parts, which is first is the power supply, The power supply will generate high voltage, which will be transferred into the transducer, the red one. The transducer works as a converter, which changes the high voltage from the power supply into the high frequency mechanical vibrations, and then it will transfer again into the booster, the yellow one. This booster acts like an amplifier. It multiplied again the mechanical vibrations and transferred into the horn. The horn, shown in number 4, will apply pressure to the parts that will be joined, and another parts that already clamped in the fixture, the clamping devices. So, how it works? The ultrasonic welding usually works in only 3 steps, where the blue one is the horn that I already showed. The horn will apply pressure to these materials. In this case, it is the plastic materials. Let's call it the yellow part and the pink part. First, horn will directly apply pressure to the yellow part, and then it will also apply pressure to the pink part, and then it will makes the horn to vibrate because the mechanical vibrations, it could be vibrate vertically or horizontally, range from 20,000 to 40,000 times per second. And then because it produces mechanical forces and friction forces, it will generate heats that causes the microstructure of the material to melt and flow together. So you don't have to put external metal to make it joint or another external heat. Some important factors in ultrasonic welding is the how much time you spend to apply the horn to this yellow part, which is called as the hold time, and then the welding time, which is the how much amount you let these two parts to fold to each other, and then the welding head pressure is the amount of pressure you put to the horn, hence it could be applied also to the material that you will weld to each other. And then there's amplitude rods and converters. Advantages and disadvantages of ultrasonic welding. The first advantages is it is automated and fast, so it is suitable for high production rates that usually the main goal for the industry, and that it produces high strength joints, so it will not easily yield and fracture or crack, and that it produces clean and good surface finish, which just minimize the microscopic or microstructural defects such as porosity, and that is able to weld a variety of materials such as steel and with aluminum, and then metals with plastic, etc. And then some disadvantages are some process of ultrasonic welding need custom horns and fixture, therefore it really costly and very high cost for the maintenance itself, and then it cannot really join at thick parts, especially the hard metal, so it has several restrictions with its thickness. For the aluminum, it has maximum thickness 2.5 millimeters. Because this ultrasonic welding machine produce vibration that convert the high voltage into the mechanical vibration, it may damage the electronic components, so be careful with that. And then its application usually found on the nuclear reactor components because it needs strong and small components. So ultrasonic welding is suitable for this nuclear reactor components welding, and that is usually found also in the automotive and electronic industries. And then because it produces clean and good surface finish, it is suitable for medical industries which make parts for filters and mugs. Okay, that's all for me. Thank you very much.
Hi everyone, my name is Wahyu Budi Arta. Let's continue our discussion about welding. The next topic is about friction welding. So, The friction welding process is the rotation of workpiece in the sliding between rubbing surface and the produced coalition of metal by heat obtained. Hence, friction welding is not a fusion weld process but a solid state weld process where the resultant joint is often as strong as the parent metal. So, what is the process of friction welding? This is the schematic of friction welding. To perform friction welding, we need a machine. The machine is like a latte manual machine that has set stop to perform rotating. So the metal is rotating and the other metal is non-rotating. The non-rotating metal is moved toward the rotating metal to make a friction. If the friction happens, the heat is produced. After the heat produced, the weld is performed and the material is joined together. To see the better understanding, let's see the video here. So the video is from TWI and Tech Insider. So that is the friction welding process, and the next is about the advantages and types of friction welding will be explained by my partner Aicha.
Okay, thank you. Now move to the types of friction welding. There are 4 primary types of friction welding processes. The types is classified into 2 big categorial. One is required a non-consumable tool, while another one do not. Let's go through each one of them. First is rotary friction welding. This type of welding uses compressive axial force and high rotation speeds to plasticizing the materials and create bonding. It has 2 primary mechanisms for delivering the energy to the weld interface: direct drive and inertia welding. Next is linear friction welding. This type of welding uses materials to oscillate in a reciprocating motion in relation to the other at high speed with high compressive forces to plasticizing the metals and create the bonding as well. Next is friction stir welding. It works by using a non-consumable tool which is rotated and punched into the interface of the workpieces to soften the metals and create the bonding. The fourth is friction stir spot welding. This type of welding is the variant of the previous type of welding. It works by rotating, plunging, and retracting a non-consumable tool into two workpieces in a lap joint configuration to make a spot weld. Now move to the benefits and drawbacks of this type of welding process. One of the major advantages of friction welding is that it can be used to join dissimilar metals. Friction welding does not require any external heat or flux, keeping the process easy and less messy. Since it categorizes as a solid state welding, it contains minimal or no defects when compared to fusion welding, being easily automated, making the process highly repeatable and not depend on human influence, resulting in a very fast process. Does not need much surface preparation, being able to reduce the material required. Along with the benefits, there are also several drawbacks in this welding process. One of the greatest disadvantages of friction welding is that it has limitation to workpieces dimensions, joint designs, and the workpieces need to be fixed. Besides that, friction welding equipment is high cost and materials that cannot be forged one weld.
So for this opportunity, I would like to explain about resistant welding. Now we go directly to the definition of resistant welding. The resistant welding is the weld is made by connecting a strong current through the metal combination to heat up and finally melt the metals and localize set point determined by the design of the electrode and of the workpiece to be welded. A force is was applied during, before, and after the application of current to confine the contact area of the weld interface and in some application to form the workpiece. Then we go to the working principle of the resistant welding. The working principle of resistant welding is the generation of heat because of electric resistance. The resistant welding, such as seam and swarf, work on the same principle. Whenever the current flow through the electric resistance, the heat will be generated, and the same working principle depends on material resistance, applied current condition of a surface, and the applied current time period. This heat generation takes place because of the energy conversion from electric to thermal. Then the resistant welding formula for heat generation is H equal to I squared times R times T when H is the generated heat and the unit is joule, when I squared is the electric current with the unit is ampere, and the R is electric resistance with the unit is ohm, and T is the time of current flow with the unit is second. Now we go to the types of resistant welding. It divides into 4 types. The first is the resistance spot welding. The spot welding is a resistance welding process for joining metal sheets by directly applying opposing force with the electrode with pointed tip. This spot welding is widely used in process of automotive industry for assembly automobile bodies and large components. It's also widely used for manufacturing of furniture and domestic equipment. That picture shows the schematic of resistance spot welding. Then we go to the second type, which is resistant projection welding. The projection welding is resistant welding process for joining metal components or sheet with embossment by directly applying opposing force with electrodes specially designed to fit the shape of the workpiece. This projection welding is widely used in electrical, electronics, automotive, and construction industry and manufacturing of valves, pumps, and sensors. Then the third type is the resistant seam welding. The seam welding is a resistance welding process for joining metal sheets in continuous, often length-tight, seam joints by directly applying opposing force with electrode condition of rotary wheels. The current and the heat generation are localized by peripheral shape of the electrode sheet. Then that picture shows the schematic work of the resistant seam welding. This seam welding is mostly applied in manufacturing of containers, radiator, and heat exchangers. Then the last type is the resistant butt welding. Butt welding is a resistant welding process for joining thick metal plates or bar at the end by directly applying opposing force with electrode clamping the workpiece. And the picture shows the schematic, and this butt welding mainly used or applied in manufacturing of wheel rims, wire joint, railway track joints. After knowing that, the last part is the advantage and disadvantage. Then we go to advantage first. The first advantage is this method is simple and does not necessarily high expert labor. Then the resistant welding metal thickness is 20 mm and the thinness is 0.1. The automated simply. Then the rate production is high. Both related and different metal can be welded. Welding speed will be high, and the last is it doesn't need any flux, filler metal, and protecting gas. Then we go to the disadvantage. The tool cost will be high. The work section is limited because of the current requirement. Then the third, it is less proficient for high conductive equipment. It consumes high power, electric power, and the last is well joint, contain a small tensile and fatigue power. So that's all for me. Thank you.